Hello and welcome to a screencast about modeling with linear functions. So modeling takes place with lots of different in lots of different ways. I decided to use some data for this particular video. So students in a chemistry class measured the volume in milliliters and mass in grams of samples of distilled water. The data they found is given on the table below. Okay, so we've got some values for volume and values for mass. So mass depends on volume. So we can certainly say that this is our input and this is our output. Let's use some variables too here, and let's not use x and y because that just doesn't make any sense or it's not meaningful in this context. So I'm going to use v and I'm going to use m. So looking ahead a little bit, I've got a capital M here, so that means that little m is going to be big M of v. Okay, first question here then. Why is it reasonable to use a linear function to model this data? So we've answered a question similar to this in previous screencasts. So we know that linear functions have a constant average rate of change. So you could certainly go through and pick out the different average rates of change with this data. So pick like 20 to 40 and then 60 to 80 or 20 to 100, like whatever. So no matter what intervals you pick, you should always end up with a constant average rate of change. Okay, I'm going to look at this one a little bit differently though. So I want to know, what is my change in my volume? So this little triangle symbol here means delta V. So looking at our table, you notice that it changes constantly. This is not always going to happen. I fixed this table. Okay, so my delta V is 20. Does the same thing happen with my M, my mass? So my delta M, sure enough, 19 to 41, 41 to 63, etc., etc. My change here is always 22. Okay, so to answer our question here then, so we have a constant average rate of change, which means that we're going to have a linear function. Okay, what is the slope? So that was where my delta V's and my delta M's are going to be helpful for us. So slope, remember, is your rise over your run or your outputs over your inputs. Okay, so this is why you don't just want to think like the change of y over the change of x, because what is y and x? Okay, so in this context, we're going to be looking at the change of our masses, our outputs, over the change of our inputs, which is volume. Okay, so using the values we just found up above, this is 22 over 20, which simplifies down to 11 over 10, or 1.1. Units, so units of slope or average rate of change is always something per something. So in my numerator, I'm measuring masses, so that's going to have to be in grams per. My denominator is volume, that's being measured in milliliters. What is the meaning of the slope in this context? Okay, so meaning is important in this class. We can crunch numbers all day long, but what do they mean? So 1.1, would you say that's a positive number or a negative number? Well, I would say it's positive. Okay, so that must mean that our mass has to be increasing. And looking at our table, it is. So we could say that the mass is increasing. How is it increasing? So it's increasing at 1.1 grams per milliliter. I'm just going to write ml here because my pencil's not cooperating. Okay, great. What else do we have up our sleeves here? So these modeling problems tend to go on for a while. Okay, same situation here, same data, everything else. If we required a mass of 70 grams, what volume should we have? Okay, so if I look on my table for my masses, do you see 70 on your table? Of course not. So 70 is somewhere in here, right, between 63 and 85. So that must mean that my volume has to be somewhere between 60 and 80. Okay, gut check, that's good to know. But yeah, there's a lot of numbers between 60 and 80. Okay, so what we're going to do then is, we know this is a linear equation, right? So we can find an equation for our line. Let's remind ourselves what the equation of a line was. So y equals y naught plus m, our slope, times x minus x naught. Okay. All right, so y in our case is our output, so we were calling that m. So I'm going to go down here and rewrite this equation. So m equals, so y naught and x naught then is just any point on your table. Pick a point, any point. So I'm going to go ahead and use this first point here. So then the 20 is going to be my v naught or my x naught in this formula, and then my input, and then the 19 is my output. Okay, so anyway, so this is going to be 19 plus, my slope we said was 1.1 or 11 over 10. So I'm going to write it as 11 over 10 times the quantity. Instead of using an x, remember our inputs were v's, minus then our initial value, or our value that we're using here for our v is 20. Okay, so that's just our equation. We have not even begun to answer this question, but this will help us for this problem and the next problem actually. Okay, so if I require a mass of 70, so that means I'm going to go ahead and plug in 70 for my mass. So 70 equals 19 plus, let me go ahead and distribute this value through. So 11 over 10 v, and then that's going to be minus 22, okay, because the 20 divided by 10 is 2, so 11 times 2, 22. All right, I am going to, I guess it really doesn't matter which order here, but the 19 and the 22 are going to have to get scooted over here with the 70. So let's see, that gives us a -3, so we add that over, so that's going to be 73 is 11 over 10 v. Okay, to get rid of that fraction front, and this is why I used a fraction instead of a decimal, because it's a little bit easier to work with when we're doing stuff by hand. Okay, so all that stuff's going to cancel because you multiply by the reciprocal. So v is going to be 730 over 11, which I cranked out ahead of time to be 63.36 repeating milliliters. Okay, does that fit our gut check? So is 63.36 somewhere between 60 and 80? It absolutely is. Okay, last problem. If we have a volume of 50, so that means I'm going to be plugging that in for my V, what mass should we expect? So again, let's look up here at the table. 50 in our volume falls in here. So that means I'm expecting my mass to be somewhere between 41 and 63. Okay, so let's crank this out and see what we get. So M, my mass, is 19 plus 11 over 10 times 50 minus 20. So that gives us 19 plus 11 over 10 times 30. Okay, so that's going to give us 3 if we do 30 divided by 10. So that's 19 plus 33, which gives us a grand total of 52. And it's 52 grams because it's a mass. Okay. Does that fit our gut check? Is 52 between 41 and 63? Yes, it is. All right. Hope this helps, and thank you for watching.